everybody, in this video we'll talk about expanding a logarithmic expression, problem type 2. In order to do this, we need to know the properties of logarithms, and you can find this in the video expanding a logarithmic expression, problem type 2, and basic properties of logarithms. So when we take a look at this log, we have log of 4 to the y over the cube root of x times z squared. So what we want to do is we want to expand this logarithm so that each logarithm only has one variable and should not have any radicals or exponents. So when we're working with this, the first thing I notice is that I have a quotient here, which signifies there's going to be some subtraction. So this becomes log of the numerator minus log of the denominator, and the entire denominator is the cube root of x times z squared. There's a few different paths from here that we can take, but if you remember, what is the cube root in exponents? That is the same thing as having x times z squared to the 1/3 power. So far this entire thing is log of y to the 4th minus log of x times z squared to the 1/3. So the power rule says I can take this 1/3 and stick it out in front of my log, so it's 1/3 times the log of x times z squared. And I can do the power rule with this 4 as well. So 4 times log of y minus 1/3 times the log of x times z squared. Now this 1/3 is being multiplied by this entire log, right? But this log has a product in it. So I can expand that log in order to separate the x and the z to be log of x plus log of z squared. And then I still have the minus 1/3 out in front, and I still have 4 times log of y there. Now this isn't fully expanded because I then need to multiply the negative 1/3 down, and I also have some exponents. I have this z squared exponent. So let's first multiply that negative 1/3 through. So 4 log of y minus 1/3 times log of x, and then that negative 1/3 needs to be multiplied by log of z squared, so that's minus 1/3 log of z squared. Now again, I have an exponent, this 2, so I need to multiply this 2 down through here, which would be 2 log of z, but I still have the negative 1/3 multiplied by that 2, and this portion simplifies to 1/3 times 2 is 2/3 log of z, and then we have 4 log y minus 1/3 log x minus 2/3 log z. And that is expanding a logarithmic expression, problem type 2.